Hello, everyone, and welcome to yet another interesting conversation on this channel. I am Alex Bolboaca, coming to you from the Mozaic Works studios. And my guest today is somebody who is an agile software development consultant, a trainer, an author, somebody who has been a keynote at ITECAN conference, and this is where I first met him, and the author of one of the largest books I know, and I have. It's about 700-page book, X-Unit Test Patterns. Very useful book. So welcome, Gerard Meszaros.
Good morning. How are you today?
I'm good, thank you. So you live in Canada, right? So it's quite morning for you.
Yes, it's morning here. We just had our first major snowfall of the season. I have 15 centimeters on my deck, and I live just west of Calgary near the town of Banff, Alberta, just outside the national park.
So what I wanted to, and what I like to do first with everybody who I discuss with is to ask you a bit about why you pick this career, why you pick software development, and how you ended up writing this book and doing the agile consultancy.
Well, that's a long story. I'm not sure we have time for all of it. Um, I was always, somewhat interested in technology. I remember taking apart all sorts of things like alarm clocks and stuff at home. This is back in the days when they were full of gears and springs. And when I went to university, I had to pick, some subjects. Obviously, I took a science degree and ended up doing the usual major science courses: chemistry, physics, calculus, statistics, and there's this new thing called computers, computer software, computer science. That sounds like it could be useful in whichever career I end up in. I thought I'd be doing physics or statistics or something, so I took as my fifth course the main level of computer science, and by the end of the first semester, or first 4 months of university, I'd already realized that this is probably the most interesting of all of them. And so I ended up in second year and beyond focusing on computer science. So that's how I ended up working with computers. Just to set the context, when I started working in computers for the first 2.5 years of university, I did all my programming on punch cards. And then in the third year of university, we got an online account. It's called a TSO account, a time sharing something or other account, on an IBM 370, I think it was. And we got to submit virtual card decks from a text editor into the batch programming system. So it was a very different world then, and the turnaround time for every time you edited your edit, compile, test cycle was approximately 20 minutes, because you had to line up for a card reader or a card punch to make your edits to your program, and then you had to carry your card deck over to a queue and stand in line to wait to submit your card deck, and then you had to stand in another line to go and wait for your printout to come out of a huge big beast. So very different style of development from what we do today. And I ended up, after graduating, having a bunch of different job offers, and the most technical one of them all was working at the research and development subsidiary of Northern Telecom. It was called Bell Northern Research. It was located in Ottawa. The BNR acronym was invariably expanded to a different definition, which was the Big Nerd Ranch, because that's where all the nerds went to work. And so that's how I ended up in telecom, because it seemed a lot more interesting than writing COBOL programs for some, like the Canada Wheat Board, which was another one of my potential jobs, or the Manitoba Hydro, and these big companies that used some IT inside them, versus a company whose core competency was computers and operating systems and telephone switching systems, which are basically large reactive real-time systems. So I ended up working for BNR for 14 years. We had a proprietary programming language that was highly optimized to work with the proprietary runtime system on the switch. We could go down into the basement, into a room the size of most people's living room or entire house. That was what we called it, a captive office. It was a switching office, as they call it in the vernacular, that we could load our software into dynamically. So you could bring your particular extension to the code down on a tape and mount it on a tape drive and load it into the system while it was running, and start executing your code and making different kinds of phone calls from the ones that were possible to do beforehand. So there, our compile, edit, test cycle was not 20 minutes, but often several days, because you had to wait for your appointment. You'd book a 4-hour shift or something on the captive office to test your software. So you learned to be pretty careful and make and think through things really well, so that there was a pretty decent chance of having your software work the first time you tried it. So I did that for a number of years, and then got into managing those people, first level supervisor, team lead, whatever you want to call it. And I also was involved in introducing object orientation to the software that we were working on. Worked with the compiler groups to add full object support into our system. We had kind of an object-based system. We had, in order to build a 30 or 40 million line software program, there is no such thing as a main program on a system of that size. There's a whole bunch of processes running, doing different kinds of things, and the software is linked into it dynamically. So we already had dynamic binding of sorts, but we just kind of promoted it to the full equivalent of, something like Object Pascal or, other, or C++ kind of thing. In fact, our biggest competitor at the time was AT&T, and all their systems were built in C, and we considered that one of our competitive advantages, because our system, unlike C, was extremely type safe. Everything was oriented towards removing the opportunity for us programmers to make mistakes. We had runtime checks on descriptor bounds, so array descriptors. So when you indexed an array, there was no way to walk off the end of it, because the descriptor told the runtime system how big the array was, and if you tried to go one entry off the end of the array, it would trap it and throw an exception. Don't you wish that all the C programs that browsers and stuff are written in had that? And we wouldn't have so many exploits in our browsers if that was built into our modern runtime systems 30 years later. So we were so far ahead of the times, it was scary. When I left Nortel and got into working for a small consulting company in Calgary, and it was partly a lifestyle move, but partly I decided after 14 years, if I stayed at Nortel, I'd have to stay there for the rest of my career. And the career progression path was into to senior management, and AVPs and VPs, and our joke name for AVPs, assistant vice presidents, was assistant view graph presenter, because all they ever seemed to do was do presentations on plastic foils on overhead projectors. So I didn't want to spend all my time doing presentations to potential clients and stuff like that. So I wanted to stay technical, and there wasn't a good technical career ladder. It's ironic, in the hardware side of the business, if you got a really important patent, they would promote you to the equivalent of an assistant vice president and give you a staff job, working technical stuff. But there was no equivalent in software. There was no way to get above kind of second level management. It was really as far as you could get. And I fought that battle for a number of years, broke some cracks in the glass ceiling, but left before other people managed to break through it and get to the third level of management as a technical person. But when I moved out to Calgary to work for this small consulting company, it was like walking back into the past, because I'd been using version control systems since I started at Nortel in 1981. And here it was 95, and most people still didn't have a version control system. And we had email like native running email on our computers in 1981, and in 1995 Windows 95 had just come out, to set the context, and to get your email you had to dial up over a phone line, from any, wherever you were, your office, your home, etc. I mean, we only had to do that at home at Nortel when we were dialing in to support a build failure. But at the office, all the email was directly connected to networks and stuff. So it was quite a shock moving from a very technically sophisticated organization out into the real world, IT world, where people were still walking software around on floppy disks. We called that the sneaker net. So it was quite ironic. Well, at least we weren't using punch cards, but for all the sophistication of desktop computers and laptops and stuff, the way networking was done and the way software code, source code was managed was really quite scary. There were literally, in many large organizations, which were using software to run their businesses. Like I worked with a large pipeline company in Canada and a large railroad in Canada, etc. They would have hundreds and hundreds of applications running various parts of their business. But in many cases, they couldn't change their applications because they'd lost the source code. They only had the executables. So that's how in many ways primitive things were. This was before the days of Git and GitHub and that kind of stuff. If you were lucky, they had CVS or something proprietary. I can't even remember the names of some of them, but they were awful. The source code control systems were awful. It was all pessimistic locking stuff. One person could basically keep everyone else from working because they'd locked something and gone home for the weekend and then came back the next week everyone comes into work and no one can change the software because that person got sick or forgot they were going on vacation and left an important piece of code locked.
Yeah.
An administrator had to override it to basically steal the lock back from them and stuff.
I remember Visual Source Safe, who was using that kind of thing, and also one of the problems with it is that it used to get corrupted from time to time, so you had to have backups because otherwise. Yeah.
That's right. Yeah, Visual Source Safe, VSS. That was one of them. Yes, I remember that one. If you were working in Visual Basic, that's what you had to use. Yeah.
So it's interesting what you have been saying about Nortel. I didn't know it was so advanced from the technical perspective. How are you testing software in that context?
Well, it was interesting. We had very much people were full stack developers. You did your own requirements work. You worked with the what we'd now call the product owner, who a product manager on the Nortel side, and then the software developers were on the BNR side. And we would work with the product manager to understand what it was that they wanted built. And we were building systems features by feature. Like when I joined Nortel in 81, we were on BCS was the kind of the name we called the thing, the bulk change supplement, which was basically a 3 times a year delivery release train by SAFe terminology. And we were on release 8, I think was the first one, or 7 was the first one I contributed to. And when I left in 95, we were on something in the high 30s. So we were doing 3 releases a year. The developer would talk to the product manager, find out what they wanted. They would write it up in a requirements document. And we had a very specific format template that we followed. There were like 10 different sections to this document, starting from the requirements, which you then review with the product manager, and then we would have a data schema section where we would describe how we needed to change the on-switch database, and then there was a design description where you described how the software would be structured, and then there were sections for the operational measurements or metrics and alarms and various other sections. And the developer would write all those different sections. There was reviews of each of the sections. In the early days, you had to go and fill out paperwork to get a change number in the version control system. Later on, you could just go and create a version, a change number against which you applied all your, basically your edits were all done under a change number, and then you would later on you would commit them back into the repository, and then you would when you had your software at a point where you thought you were ready to test it, you would book some time on the captive office, and if you were doing call processing, which is where I was involved, you would literally go down into the lab with the tape under your arm, you'd mount it, you'd load the software into the switch, you would go into the database editor, you would add some new feature or something onto one of the telephones. There was like 20 telephones hanging on the wall around basically we had these low-walled Herman Miller horseshoes in the captive office, and there were telephones mounted on the low walls, the old kitchen style hanging telephones, and you'd pick one up and listen for dial tone, and you'd dial a few digits and listen, and dial a few more digits and listen, and if you got dial tone back, you'd walk over to the printer that was printing out the software error dump that was caused by your software. And then once you realized that, okay, I broke it, you would then go into a terminal and set a breakpoint in the software and make the call again, and then you would single step through the code to see what the code was doing, or you would turn on a tool that recorded the execution path for your particular software process. It would trigger on a kind of a breakpoint like thing, and then you would get this ginormous printout on a deck writer in the office that would print out basically the call trace, all the procedure calls nested down deeper and deeper, and that told you exactly what software executed and what line of code it was or what offset in the code. Then you have to go onto the mainframe editors to figure out what that translated to in source code level, because you had to look at the compiled listings to figure out what offset each source code statement was compiled to and stuff like that. So it was definitely laborious and tedious, although it was exciting. It was amazing how if you booked a midnight shift, which was the best shifts if you wanted to do stuff that could cause the switch to break and go into restart loops, you could go home after work, have dinner, do your evening routine, and then head back into the office at 11:30 at night. Get your lab time at midnight, and you'd be working away, and people would start coming in. You say, "What are you guys doing here?" "Well, it's 7 o'clock already. It's time for doing our regression test on the switch," and you wouldn't even realize you just spent all night working away. You get into the flow, and time would just pass so fast that it was scary. So then you'd go down to the cafeteria, have breakfast, have coffee, drop by the office, give the boss the results of your work overnight, and then go home and have a nap. So that was how we did testing. We also, interesting enough, we had a whole bunch of automated regression testing, and there was a dedicated team whose job was to build a regression test suite. And you have to understand that when you're building regression testing for a telephone switching system, the thing you are running the tests on is another switching system. So to test the trunking between two telephone switches, you hook up trunks to another telephone switch that is programmed with the test software. And if you're testing telephone lines, the old wired telephones that you picked up and dialed the rotary dial or pressed the buttons, then you had to have special hardware on that machine which simulated being a telephone. So there was a line card on your main telephone switch, the one that you were testing, that had 2 or 4 wires coming out of it, and those wires would be physically wired to a card on the other machine that was a telephone simulator that did the equivalent of off hooks and sending pulses and dials and that kind of stuff. So it was a big deal to do automated testing in those days. But there was this group, like we had 500 software developers or something where I was located, building various aspects of the software, and I think the regression test team was something like 20 people were working on all this software and they were constantly trying to add new tests that test new functionality onto the regression test hardware and software, and they would run regressions every night. Typically we would do a software build every night, and it would take many hours to compile the 20 million lines of code or whatever in the system. And so every morning we'd have a new compile to compile against. And then there was a weekly official build. So you wanted to get all your changes committed by the 4 o'clock on Tuesday, so that the Wednesday build, Wednesday or Tuesday night overnight build could include them. And then Wednesday morning you'd come in and find out how the build went, and people would be getting phone calls if their code wasn't compiling or their code was causing the switch when the code was loaded to go into a restart loop. And sometimes the load would come up insane, and they would have to go and do a recompile because the changes to fix it were too big and had ripple effects throughout all the code. So it was quite a production to build a system, weekly builds and new software release every build, internal releases for an organization with. At our site we had 500 developers, but we had 3 or 4 other sites, each with several hundred. So we're talking 1,000 plus developers, all contributing to a single code line. And doing a weekly build on that, and if you were doing something that had significant impact, wide-reaching changes, changing global data structures that affected everyone, you had to get in very early in the life cycle of the build. So every week's build was labeled with a letter, so you wanted to get in on the A, B, C, D builds to get those changes in before people started piling on the smaller feature changes on top of that. And after a number of years, we ran out of letters because it would take us more than 26 weeks from first build to when we released. So then we started going into double letter build numbers and stuff like that. So that was interesting.
Yeah, and this was happening in the 80s, right?
Yeah. I started in 81, and I was a developer through 84, and then a first level manager through about 90, 88, 89 or something. And then I was a middle manager through 95 when I finally left Nortel.
While you were there, was there any time a situation where you had a huge problem in production with these systems?
Oh yeah, it was really interesting. Every month we had an all hands meeting where the big boss would come up and tell us how things were going. And one of the quality measures in software in switching systems is downtime. And so our downtime target for each switch was 2 hours downtime every 40 years. So think about that. How many nines is that in terms of reliability?
Yeah, I don't know.
And I remember when I first arrived there, and I went to one of these first all hands meetings, and there was this kind of a standard agenda. They would go through various things. They would go through the downtime statistics. At that point we had, 500 switches in the field, and this downtime obviously was averaged across all the switches, but I think we were in the 6 or 8 or something hours downtime per switch on average at that point, and it was trending down. And so every major outage in the field was described at this thing, and they did root cause analysis on it, what we'd call 5 whys these days. And I remember one was hilarious. So this was an outage at a scope dial switch, which is a military PBX on one of the big US military bases. I think it was in Nevada or Arizona or something. And what happened? Well, the switch went on to, there was a power failure. The switch went on to emergency backup power, and then it died. So what happened? Well, it turns out that the sergeant in charge of keeping the switch running Actually, his job was to make sure that the batteries that kept the switch running if commercial power was lost didn't get discharged. And there was a commercial power failure, and he noticed that the batteries are being discharged, so he disconnected the switch from them so that the switch couldn't discharge the batteries. So he unplugged the switch from the batteries, and the whole purpose of the batteries was to keep the switch running, right? This is a classic example of what happens when you give someone very specific instructions and don't give them the big picture context for those very specific instructions. So that's what happens when you micromanage. And so, I mean, that was a classic example of there was a 2-hour downtime caused by this commercial power failure, caused by a person misunderstanding their instructions, caused by, etc. So it was entertaining. There were other ones where we had, I remember there was one where we spent months solving this problem in Alaska. It was a new switch up in Alaska. It was using it was one of the first switches with signaling system 7 or SS7, where they have common channel for signaling. In the old days, all the signaling for the trunks was in the channel. So before, you kind of went off hook on the channel, just like a telephone, and you sent some pulses or some tones down the channel, and there was a tone receiver on the far end. And this idea of doing the signaling in a separate channel was new. And so we were working on this switch in Alaska, and it kept crashing. And it was crashing so badly that you couldn't even get into the switch on a terminal. On site, a physically connected terminal had no response. Like, it would take 20 seconds for each character that you typed to get reflected back to you. And so clearly something was going haywire inside the switch. It was eating all the CPU time. And so we had to rewrite the runtime scheduler and reload the switch with a new scheduler just to get terminal response. So once we got terminal response, then then we can get in there and start looking at the status of things. And it turns out that the problem was caused by this new common channel signaling software. And it what happens is, for redundancy, everything in telecom is redundant. So the switch has 2 CPUs that are running side by side the exact same code, and there's special hardware that monitors them to make sure that they're working identically. And if they get into a mismatch, then they get into a whole dispute resolution process to figure out which one is wrong. All the trunks have multiple channels, and each of the channels, they're routed in different ways. So here we have this common channel signaling. The hardware, they have a main signaling channel and a backup signaling channel, and they go out onto 2 different cards, and the 2 different cards are attached to 2 different sets of wires. And the idea is that if you lose one signaling channel, then you switch over to the other signaling channel. And so the thing was switching back and forth between these 2 channels, and it would get switched to the other one, and it would notice that it wasn't very good, so it would switch back to the first one, and notice it wasn't very good, it would switch back to the second one. So it was switching back and forth. So all this high priority work of recovering the signaling channel was eating all the CPU on the switch. So the on-site techs go out there and they kind of follow the wires. And so these 2 wires that the signaling channels are running on, or 2 DS1s, go out of the switch. They go via very different routes, and they end up at the exact same satellite station. That sends a signal to a satellite, which then goes down to the US lower mainland. And okay, that's not a good thing. That means it's not really redundant. There's a single point of failure. But why is everything crashing? And it took them a while to figure out that occasionally a herd of migrating caribou would stand in front of the receiving dish, and the cloud of steam coming off their backs would disrupt the satellite signal.
That sounds like the original story about bugs, where the name bug comes from, because bugs were actually eating wires.
Yeah, so the moth was stuck on the coils of the old core memory. Yeah, it's a very similar kind of thing. And Another time, a friend of mine was working on trying to fix a bug, and the system would work just fine for 20 minutes, 30 minutes, and then it would go into an infinite loop. And so he's trying to figure out how does he set a breakpoint in the software so that he can stop things and take a look. How does he know the thing happened? And he scratched his head about this for a long time, and then finally figured out that if you put an FM radio next to the CPU, it would make a certain kind of random staticky pattern noise, and then when it went into infinite loop, the pitch changed. So he actually used a radio, like a Walkman or something, as his way of debugging the hardware to figure out when the problem occurred, so he can set his breakpoint. Yeah, those were the good old days. Very different from now, where everything is virtual, including our meetings. Back then, it was all about the hardware.
Yes, and I imagine so having this experience, and then as you mentioned, you switched to consulting, and you started seeing what was happening in the software world, and it was probably very different. Besides this idea of version control and how the software was managed, but I also imagine that object orientation was not as spread out, and
Yeah,
the
well, in
way
fact,
to manage software and so on.
yeah, I mean, one of the reasons I was approached originally, I was headhunted out of Nortel by this small consulting company in Calgary. They were looking for someone with experience with object orientation to use as kind of team lead software architects, project managers, working with their clients who were interested in learning better ways of building software. So that's kind of where I switched from direct software development and then management of software development to teaching people how to do software development. And as I mentioned earlier, Nortel, BNR in particular, was highly technically competent. In fact, we had such a high opinion of ourselves that we wouldn't hire consultants because it would take too much time to bring a consultant up to our level of knowledge of our systems that they could actually provide us with advice. Now, I did actually hire some consultants to help us learn object orientation, but that was the exception, not the norm. And in fact, I remember, do you remember Star Wars? Not the movie, but the Ronald Reagan Defense Initiative?
I remember hearing
SDI?
about it, yes. But
Yeah, so it was called SDI, or the Strategic Defense Initiative. And the idea was to shoot down incoming intercontinental ballistic missiles. When that was first proposed, it was some software experts in the industry were consulted about how hard it would be to actually implement all the software and test all the software and make sure that it worked to control the anti-missile missiles. And their opinion was that there were only 2 organizations in the entire world that had the technical chops to do it. And one of them was BNR. And I can't remember who the other one was, but it was like, it was considered that it would be a 50 million line software system, and the only other systems in the world that were that big and working and successful and good quality were telephone switching systems. Because I mean, telephone switching systems were the original mega systems. I mean, we were 10 times the size of anything else at the time.
And they had to work.
So, and they were used every day, which was, part of the advantage. And they had to be built highly incrementally. I mean, we were adding new features, new kinds of trunks. Every country went into, we had to implement their local protocols because every country had their own variations, usually introduced by the dominant vendor there. So you could tell who was the original vendor of telephone systems in a country just by looking at which protocols they supported. So there were the Alcatel countries and the Ericsson countries and the Nokia countries and the Ericsson countries and the and so on. So if you tried to go into another incumbent's country, you had to re-implement all their protocols. So it was a huge moat that every telecom provider had effectively built in their kind of client set. But you were asking about the what it was like when I went out into the real world from the
Yes.
highly technical enclave of Nortel, And yeah, it was quite a shock going back to the back 10, 15 years earlier kind of world, and getting used to working without all the technical supports and safety nets and just the sheer discipline. I mean, when you're working in an organization with thousands of developers, there's a very high level of discipline in how you do things, and part of it is imposed by the processes that have been put in place to try and allow all these people to work together and not have chaos. And part of it is the technologies that you build to support those processes. And basically all of that was missing out in the IT world. And when I say IT, I mean, by that, what I mean is companies that use technology to run their business, but technology is not their business.
Mm-hmm.
And part of the difference is the attitude that IT is a cost center, not a profit or opportunity center. So it totally changes the mindset. And the other thing is, I mean, I remember when Peopleware came out, the first version back in, I'm going to guess it was about 83, 84. And I remember doing a course with Tim Lister on project management. And the mantra was, if you can't measure it, you can't manage it. And there was the big project management book that Tim had written with, who is the other guy now? But anyway, Tim Lister wrote this book called Peopleware, and one of the things they did was surveyed organizations and the people who worked there, and they found there was a 10-to-1 difference in productivity between the best and least effective workers in an industry, and within an organization it was only 5-to-1. And why was that? It was because people self-selected into organizations. So someone who's at the top of the scale, 9 or 10, times as productive as the lowest productive person, wouldn't tolerate working in a place that hired people who were in the bottom quadrant. So they would either just not sign on there, or they would be there for a short while and realize, no, I can't work in this environment. I'm spending too much of my time trying to bring other people up because they don't have the technical competencies and the aptitudes. And one of the things you found is that people had self-selected, just like I had chosen not to go work for an oil and gas company in Calgary or the wheat board in Winnipeg or Manitoba Hydro. I had chosen to work at Nortel, and particularly their most technical part, which was BNR, partly because that was the kind of work that was attractive to me. So when you go out into the IT world, all of a sudden you go from an organization where the lowest performers, who are 1/5 the productivity of the highest performers, all of a sudden they are the highest performers in that other organization that you're looking at, right? So you're dealing with people who, as a general level of skill set, partly aptitude and partly training, and partly what they've been learned on the job, and the techniques that they've learned and who they've learned from, just have a totally different level of expectation in terms of how much and what kind of quality work they can produce. And so it was quite a bit of a revelation, moving from one of the top technical organizations in the world to kind of into the run-of-the-mill IT shop, and figuring out what is achievable working with this group of people in terms of building software, and teaching them some of the more important techniques, like how to use version control systems and stuff like that, because a lot of them just weren't used to it.